will not be tumbling, and there won't be no airflow over the heater, and that could prevent a fire hazard. So we're going to have to make sure that this switch is closing for no heat, and then we have this switch here, which once the motor is energized, the contact's going to go from 5 to 3 to 5 to 6, and that'll provide power just through the main winding and bypass the start switch, and keep the motor going once it's going. Okay, so let's go ahead and let's ohm out these contacts 1N and 2N. These are the outer terminals. Right now the motor's off, so I'm not going to get a reading. There's a piece inside the motor here. It's a black collar right there, and if we can move it up and down, if we move it with our finger, pushing it down, we're activating the motor switch for testing purposes. So we push that down, and while we're pushing it down, I don't know how I'm going to do this. Thought it'd be easier. But if I want to test 1M and 2M, I'm going to put my meter leads on here, and I push it down, and I should have 0 ohms or very close to it. Okay? Now that's just checking this contact for the heater. Right now, 5 to 3 should be closed because the motor's off. So if we look in here, this one's 5 and this one's 3. And when I touch those two, I should get a reading. Right there should have close to 0 ohms. Is it getting a reading? Okay, and when the motor's running, we push down on the collar again to activate it, and it should open up and not give you any reading on the switch. When you let go, it closes back again. Now what we want to do is we want to check contact 5 and 6 on the motor. Right now it should have no reading, but once you press it down, it should give you a reading. Pause it for a second.